Today we are going to see what is banking of the road. First we will see what is the banking of the road, and also we are going to learn how to derive this equation v square, maximum velocity of the car can travel, is equal to how much radius is getting turned, what is the gravity is acting, it is a coefficient of the friction is between the tire and the car and the angle how much it's raised, okay, tan theta. This equation we are going to derive, and also v is equal to rg tan theta. This the equation is we are going to derive, okay. So I consider as the banking of the road when the car is getting as a curved path, when the car is turning in a curved path, okay. So it's going to be back tire will be sliding outwards. Many movies they showed back tire will be sliding outwards, okay. When the back tire is be sliding outwards, when the car is taking as a turn, okay, this side I taken as the applied force. Always the friction force will be create opposite to the applied force. This side the friction force will be created. Okay, the friction between the tire and road, how much friction is created will be the opposite side. The mg, the mass of the car will be acting downwards. Okay, the normal will be acting perpendicular to the road. Okay, now the question, what is the banking of the road? Banking of the road, one side of the road will be raised a little bit height compared to the another side. Okay, especially is the outer side, because when the car is getting turned, okay, it has to avoid the more friction and also topping the car. Okay, so that is the reason outside the road will be little height compared to the inside of the road. Okay, theta is the angle of the road, how much is maintaining as a difference between one end to the another end. Okay, right now what is the maximum velocity car can travel, that's the equation we are going to derive, and also without friction what is the maximum velocity car can travel, that's also we are going to discuss. Okay, first the same situation I am taken, this is a theta. Okay, the car is standing here, okay. Always normal will be acting perpendicular to the road, normal will be like this, perpendicular to the car also we can take it, because car it's in some angle. Okay, it's a banking of road, banked road, some the car one side road will be raised. Okay, mg will be downwards, you should be very clear, mg will be downwards. Car tire sliding outwards, friction will be created towards this side, friction will be created. Okay, first I am taken as a normal force perpendicular to like this. Okay, so I made small triangle. Okay, in that particular triangle we are going to mark which is opposite, which is adjacent, which is hypotenuse. Okay, so we know hypotenuse of this triangle, normal force, it's a hypotenuse of triangle, opposite is this much, adjacent is this much. Okay, this is theta, this theta is equal to this theta. Okay, now I am taken small triangle like this. Okay, it is normal force, and I don't know what is acting this side. Okay, it is opposite side, it is adjacent side, this is theta. Okay, so if you want opposite is equal to hypotenuse times of sine theta. Here what is hypotenuse? It's going to be n, so opposite is equal to n sine theta. It's very simple. If you want adjacent, what is adjacent of this triangle? Already I know adjacent by hypotenuse is equal to cos theta. We know our hypotenuse is normal force, so adjacent is equal to it is n cos theta. Okay, our normal is acting this direction. Okay, our normal is acting this direction. Because of normal, this side one force, this side one force is going to create. This is a theta. Okay, y direction will be like this because of triangular law of vector. Okay, this is opposite. Opposite I know n sin theta. Adjacent I know n cos theta. So adjacent is equal to n cos theta. Opposite is equal to n sin theta. It's very simple. Okay. Now I am going to explain about frictional force. Okay, friction force, tire is sliding outwards, friction force is acting towards. Okay, same diagram I am taken. It is a car wheel. Okay, it's going to be the car. So this side will be the friction force. Friction force. Okay, now how much it's getting angle? So how much it's getting angle? It is theta. Okay, if you are taken like this line, this is going to be theta. Okay, I am taken as a small triangle here. So it is friction. Okay, this side will be the friction, and how much it's acting, opposite side, this is going to be opposite and this is going to be adjacent. Okay, opposite, adjacent. Okay, right now our hypotenuse is going to be the friction. Okay, adjacent is equal to hypotenuse times of cos theta. Opposite is equal to hypotenuse times of sin theta. Okay, our hypotenuse is friction force. So, adjacent is equal to friction cos theta, opposite is equal to friction sin theta. Okay, now see here, I am going to in a single diagram we are going to learn everything. Okay, in a single diagram we are going to learn all the direction. See, this theta, it is a car. Okay, it's traveling in a banking road. Okay, normal will be this side. Because of the normal, this side upwards will be it's going to be n cos theta. This side is going to be n sin theta. Okay, friction is going to act this side. Because of friction, this side will be f. It's going to be f cos theta. This side will be f sin theta. Okay, two triangle we are taken, resolution of the triangle we are taken. Okay, so both this is theta. Okay, at single point mg will be acting downwards. It's very clear, mg will be acting as a downwards. Okay, upward force is going to be n cos theta. Upward force is going to be n cos theta. Okay, the force is acting toward this side is going to be n cos theta. Sorry, n sin theta. F cos theta. The force is acting this side will be F cos theta. Okay, now we have two more force also. One is n sin theta. N sin theta is parallel to this side. Okay, the same n sin theta you can write here, which is going to be n sin theta, because it's acting this side. Vector you can change the place. Again F cos theta will be acting this side. The same force you can take it here also, because this two is in a parallel. So F sin theta will be acting as a downwards. Okay, at single point this two acting downward, this is acting upward, this two acting left side. Okay, this is what we got from the banking of the road when the car is turning as a curved path. Okay, now what I am going to take it, this two equal to this, downwards is equal to upwards. Okay, downwards is going to be mg plus f sin theta is equal to n cos theta. That's it. If you want, what is mg? Mg is equal to n cos theta minus f sin theta. That's what we will get. Okay. Again, we have two force acting towards the center. The force which is acting towards the center is called centripetal force. So, what is that two force? F cos theta plus n sin theta. F cos theta plus n sin theta. We have this two force which is going to be centripetal force. Centripetal force V square centripetal force mv square by r. Centripetal force, it is mv square by r, which is called centripetal force. Okay, now solution for this. I have two equation, equation 1, equation 2. I got two equation. Just I am going to divide with equation 2 divided by equation 1. I know equation 2, mv square divided by r is equal to f cos theta plus n sin theta divided by equation 1, mg divided by n cos theta minus f sin theta. So, m get cancelled. V square divided by rg is equal to f cos theta plus n sin theta divided by n cos theta minus f sin theta. This is what we have. Okay, like this we got the equation. From that what we can do? Okay, from this what we can do? V square divided by rg. This above and below equation I am going to just divide by it's going to be n cos theta, divide by n cos theta. I will tell you why we are dividing. Okay, if you are dividing here, what I will get? It's going to be f divided by n I will get. Okay, same term, numerator and denominator you can divide. Okay, plus n cos theta. So, n sin theta divided by n cos theta. N get cancelled, we will get as a tan theta. Okay, then divided by n cos theta will be 1, because n cos theta directly we are dividing, minus f sin theta divided by n cos theta. Like this will get. Okay, now what we can do? Sin theta cos theta tan theta, sin theta cos theta tan theta. Okay, it's v square divided by rg is equal to f divided by n plus tan theta. divided by 1 minus F divided by N. This is what we have the equation. Now we need to know what is a friction. Friction force is directly proportional to the normal reactional force. Friction force is equal to, when we are removing directly proportional, you should include the constant, equality constant. Equality constant here is we are going to call it's a coefficient of friction. F is equal to mu times of N. So mu, coefficient of friction, is equal to F divided by N. Mu is equal to F divided by N. Mu is equal to F divided by N. F divided by N, you can take it as a mu, okay. So just in this equation, V square divided by R is equal to, Rg is equal to mu plus tan theta. Mu is called coefficient of friction, 1 minus mu tan theta, like that we'll have. Okay, the final solution for this, we want V, okay, we want velocity. Rg, you can take it this side. So V square is equal to Rg, open bracket, mu plus tan theta divided by 1 minus mu tan theta. This is what we have the equation. Okay, still we can do the equation. If consider there is no friction. When there is no friction, mu is going to be the 0. When mu is 0, we'll get this totally 0. This will be 0. So we'll get V square is equal to Rg tan theta. V is equal to root of Rg tan theta. Thank you for watching my channel. If you like my channel, please subscribe. Thank you for watching my channel. Thank you everyone.